Doing great. As for me, I'm perfect by the grace of God. So I'm very sorry if I did not post last week because I was normally supposed to post last week, but due to some issues, I was really occupied. So this is a question that was sent to me by a student in GBH Sancho. Yes. So I'm just going to dive directly in the question and read so that we can understand the question. And let me remind you, this video is going to be short, very short and straightforward. So I want us to be very attentive so that we can understand and go fast. So for those that are new in this video, please, if this is your first time, you can just subscribe, comment and like. Thank you very much. So the question is under complex numbers. First of all, when you get the name complex numbers, the first thing that needs to come in your mind is the Mover's theorem. Yes. So you cannot do complex numbers without studying the Mover's. No, it's not possible. So let's do the question. The question is using the Mover's theorem. Using the Mover's theorem, write down the equivalent form of cos theta plus I sin theta. That's using the Mover's theorem. And hence show that sin theta is equals to 3 sin theta minus 4 sin cube theta. So basically we're going to solve it, and it's very straightforward. Okay, as we know, the solution have been typed already, so I'll be explaining as we proceed. So the first thing you need to do is just write your solution. Solution first. That's the first thing that you need to do. I should write the solution. After writing the solution, we know very well that in complex numbers, z is usually in the form cos theta plus I sin theta in complex number. And this is a Mover's theorem. That is z to the n is equal to r to the power n cos n theta plus I sin n theta. Meaning that when you are raising a complex number to the power n, it will simply be the modulus of that complex number raised to the power n times, now you multiply the angle with the number you're multiplying with. You are raising the complex number with. So you're going to have r raised to the power n cos n theta plus I sin n theta. Yeah, so that's it. Remember, question A, we were asked to write the equivalent form of cos theta plus I sin theta. Okay, so we'll start by letting our z to be equals to cos theta plus I sin theta, and the here was normally supposed to be z to the 3, not z complement. Z to the 3 was a mistake. Yes, so you have z to the 3 is equals to cos theta plus I sin theta raised to the power 3. You can call that one equation 1 if you wish. And the z to the 3 from the properties of De Moivre's, that's it, from the De Moivre's law, z to the 3 will simply be r to the power 3 cos n theta plus I sin n theta. So z to the 3 is equal to cos theta plus I sin theta. Now people ask that where has r gone to? Actually, r is the modulus of this complex number, that is of the complex number z, and the modulus of a complex number is simply the square root of the real part squared plus the imaginary part squared. So realize that the real part is cos theta and the imaginary part is sin theta. So cos square theta plus I sin square theta will give 1, and the square root of 1 is simply 1. So that's why you're having your r to be equal to 1, which is the modulus of the complex number. And 1 raised to the power any number will still remain 1. Perfect. Okay, so that's it. I think we have we are done with the first part. Now the next passage is that we should show that sin 3 theta is equals to 3 sin theta minus 4 sin cube theta. Okay, for us to do that, remember we had from equation 1 we had cos theta, z3 is equals to cos theta plus sin theta was about 3, and equation 2 we had z3 was equals to cos 3 theta plus I sin 3 theta. So if you equate equation 1 and equation 2, we're going to have cos 3 theta to be equals to I sin theta. I mean, normally here you're supposed to have it, not I sin theta, it's I sin theta. Sorry, it was a mistake. Yes, here. So cos theta plus I sin 3 theta is equals to cos theta plus I sin theta to the power 3. Now we're going to expand this left hand side using the Pascal triangle. Yes. And to do that, I believe you have done trigonometry before doing complex numbers. So for you to expand this guy using the Pascal triangle, you realize that the power of the first term is going to be decreasing, while the power of the second term, that is I sin theta, is going to be increasing. So that's why you have cos cube theta plus 3, cos cube theta plus 3 cos square theta I sin theta minus 3 cos theta dot sin square theta minus I sin cube theta. So you realize that the power of cos theta is decreasing while the power of sin theta is increasing. And the more so that you realize that we have both imaginary and real. Imaginaries are those that are having the I, like this term, like 3 cos squared theta I sin theta is an imaginary term. So what we're going to do next is that yes, after simplification you have this. Now we're going to equate the real and the imaginary. Equating the real and imaginary, realize that cos theta is equals to, now if I want to equate the real, cos theta here will be equals to cos cube theta minus 3 cos theta sin square theta. Yes, that's cos cube theta minus 3 cos theta sin square theta. And the imaginary will be 3 cos square theta sin theta minus sin cube theta. But actually I'm not really interested on the real. What I'm mostly interested on is the imaginary. So we know very well that cos square theta is equal to 1 minus sin square theta. So if we open this bracket very well and simplify, then our proof will just come out clearly. So that's it for the question. So guys, thank you very much for watching. I just hope that this video have helped you in one way or the other. And please, if you found this video useful, don't forget to comment, like, and share the video. Thank you guys, and see you in the next tutorial.